Perfect. Perfect. Okay. Bring it
forward.
Yeah, here's what I'm seeing. Let me show you what I'm seeing. So it has like interior. Okay. Oh, that's perfect. Right there's perfect. Okay.
Do you want to do the office for anything before we start?
Nothing to think of. Okay. We're good to go here in a minute or so. Open up my drive so I can open up the midterm. Okay, all right, so we are live. Hello, students. We are going to be going over the midterm for geology. Okay, so also if you're here, be sure to leave your name, by the way, leave your name. So in the comments here, say hello, say whatever you like. Just let me know you're here. All right, so. All right. Okay, so we're going to go over the midterm, and I have here a copy of the midterm that I will be using. All right, so okay, so we're going to start, and I'm going to take you in the order that I have the questions for the lab. So we're going to start with the most simple, basic question that I can ask you. And I told you the first question on the test is going to be, what is a rock? What is a rock? All right. So let me actually field this to the couple of you who are in the live stream. 9 of you now. Awesome. Any of you want to tell me what a rock is? Any of you at all? So what is a rock? Very simple here. A rock. Anybody? Feel free to drop it in chat. Hey, that's the stuff. That's right, Daniel. It is an aggregate of minerals. An aggregate of minerals. That is what that means. An aggregate is like a congregation or a gathering of minerals, right? So, yes, a rock, the very first question on the test, guaranteed is going to be, what is an aggregate of a rock? And it'll be an aggregate of minerals. That is correct. All right, so another question I have asked you time and again. Time and again. I feel like you know what's coming. What's a map? What is a map? It is online. The midterm is online. You will not come to class tomorrow. Do not show up. I won't be there, especially those of you in my 10 o'clock class. I'll be asleep. So, all right. So what's a map? What's a map? That is perfect. That's right, Samantha. That is correct. It's a representation of Earth space to map space. Okay, a representation of Earth space to map space. Again, to those of you who are in a class with me for the first time, you will have many multiple choice questions, and these ones will most likely be multiple choice. 2 of them will be fairly close. Will be fairly close to the right answer, right? You want the right answer will be one of them. So rock is an aggregate of minerals. The other one, I might have like an aggregate of, I don't know, something else. And then there will be a third question that I like to call my I didn't study question. That will look right if you didn't come to class. And then I will have my fourth question, my fourth answer. And that is, as one of my other students described, is my Rick and Morty answer. That tends to be the something random that will not be the answer. And if you put it, I will just simply be entertained. So that's where we're at with that. Okay, so again, I'm not sure if it'll be question 1 and 2, but it's pretty close to the beginning, is what is a rock? It's an aggregate of minerals, right? Easy points here. Aggregate of minerals, okay? And what is a map? It's a representation of Earth space to map space, right? So you are taking basically a snapshot of the geography and putting it on a flat surface. Earth space to map space. All right. Let's move on here. Let me pull up my... Yes, you know, hey, if you put that, I mean, I'll be entertained. I'll be entertained. So from here, we're not going to spend a whole lot of time on the map stuff. We are going to jump right into the ways, the physical properties of minerals. So if you remember back from lab 2 and 3, before we started actually getting to the igneous, sedimentary, and metamorphic rocks, we talked about how to actually identify a mineral, right? So there are many physical properties of how to identify a mineral. So let me ask you, I'm going to get rid of this. All right. What ways, and I'd like each of you to at least give me one. ways that you can identify a mineral. And there are a couple of these that I've tried to reinforce as we go throughout and that we have used quite often. So, yep, all right, keep going, keep going. So, ways to identify a mineral. All right. So, yep, all right. So we have hardness, right? Texture. So texture is mostly correct. We are going to use a different form for that, a different word. So when we talk about texture, we tend to get into igneous rocks in particular, and I don't want to confuse you too much. So yes, we have smell, taste, streak, luster, smell, taste, streak, luster. We have our crystal form. And crystal form is the way we will define texture. Okay, they're very good. We got to right here, Ashley. Yes, cleavage and fracture. Cleavage and fracture, right? Cleavage, fracture. We will come back to that quite often. Okay. Do you guys remember one of the others, the ones I kept saying that I could not have fun with this particular object, generally pertaining to how a rock reacts to something? Do you remember this? This was one of the traits. Ways used to identify a mineral. I said they wouldn't let me have fun with it because I didn't have the proper safety procedures. Let's see, what are we missing here? That's right. Yes, Daniel, that is right. So the reaction with hydrochloric acid. All right. And I did see, I think we did miss one that was very important. That's color. So remember, as we get into specific gravity, perfect. Yep. So, and I want to have a short discussion about some of these. Color is very important. Remember, as we get into igneous rocks in particular, looking at the color of igneous rocks is extremely important. So, when we talk about hardness, we are discussing in how difficult it is to actually break, right? And do you remember the name of the scale? The name of the scale we used to determine hardness. Anybody want to drop that in chat for me? We got here. There's a scale that we use to determine hardness. It's named after a scientist who used a very, perfect, the Mohs scale. Yeah, the Mohs scale. And it seems kind of basic, but basically they took a rock and were like, what happens if we smash this rock against another rock? And then they basically ranked them in that order until got to a point where they could no longer do that. All right. So we have smell. Remember smell. If you had a chance when I gave you the kits to interact with the yellowish rock, the sulfur, right? The sulfur has a very acrid smell, as does if you had a chance to handle pyrite. Pyrite has a little bit of sulfur in there, so it has kind of a sulfurous, kind of acidic smell. Taste, again, couldn't do that this semester, but yes, certain rocks have a taste to them. So the specific gravity, do you remember when we talk about specific gravity, we're not talking about hardness or even weight. We're talking about something else. Do any of you know what we're speaking about when we talk about the specific gravity of a rock? There is a particular trait that we look at, not how hard it is, not how heavy it is. There's, yes, perfect, Daniel, density. Density, we are talking about density. All right. So, hardness, smell, taste, specific gravity, okay? And then we have streak. streaks. So you remember that I took a piece of graphite. This is the one I use the most, and they were the porcelain or ceramic streak plates, and we took that and we ran the graphite across that, and we saw that certain rocks tend to leave a streak behind that might be different from their actual color. We saw, in particular, we saw the magnetite, which is one that was a very dull gray rock, but when you ran the magnetite across the streak plate, you actually got red, which told you that there was the presence of iron within the magnetite, right? The luster, we look at how well, basically how shiny it is, the crystal form is where we look at the actual form that the rock itself, or maybe the way it forms, takes. So this can be shown in, when we have quartzite, we had the quartzite that was in the box, and you saw that it had that very nice kind of hexagonal fixture to it, where it kind of came to a point at the top, right? If I'm going too quickly, feel free to stop me. So we're gonna work our way up to the last one. So we have color. We're gonna talk about color quite a bit as we move forward. And the color is one that can tell us a lot about a rock, and we're definitely gonna get to that once we hit igneous rocks. Very important thing here. We have the reaction with hydrochloric acid, which again, no fun, we couldn't get to. I think that would have been neat, but here we are. And the last one I think we kept coming back to every lab that wasn't igneous. We kept coming back to this lab. To this trait was cleavage and fracture. All right, so those of you in chat, one of you tell me how you know something cleaves, and one of you tell me how you know something fractures. How do we know the difference between the cleavage and the fracture? All right. What do you guys got here? All right. Okay. And what does fracture do? Hold on, let me go get my rocks. Get my racks. All right. All right. Got my racks. All right. One of you want to tell me how you know something fractures? You know something fractures. So that is cleavage. Yep, when something breaks in planes, yes. So when something fractures, what is a trait that you would give that? What would a defining feature be? That's perfect. Yep. Yeah, definitely gives you the imperfect. So for example, we have, this is a piece of, let me actually give the, this is bituminous coal, right? I'm not sure how well that will translate. It probably won't, that's fine. You will see that bituminous coal has these layers, right? These layers. I know it isn't perfect here. But yes, the bituminous coal has these layers. I was gonna say, we certainly weren't gonna go a lab without breaking one of these. So, as you can see, I broke this bituminous coal. I'm not sure if you guys could see that, but come on, you guys know what I'm about by now. And you see that there is a flat plane here. That might be too, okay, I see the light is actually catching that. There's a flat plane here, right? But, and I'm not gonna break this one because I'd probably break the table first. So this is nice. I mean, yes, it's nice, but the nice is nice, okay? The nice, okay. This is nice, G-N-E-I-S-S. And this one fractures, and how do we know that? Because look at these jagged edges. There are no cleavage planes whatsoever. Right? Okay. And here we have, you guys have seen me break this, I think, the most. This is phyllite. So you see that it has kind of a stratified quality here. You have like the layers upon layers that just seem to be compressed upon one another. So, all right. Okay. So there we have that. Clear off my desk here. Okay, so of these, I believe there are 10 here. Of these 10 traits, I will ask you to name 6. I will ask you to name 6. You will have to know these. So Of these 10 traits, I will ask for 6. That is what's going to be on the midterm. I am looking at it right now. And also, I will ask you a question. I see question 4, I think, on here is explaining the difference between cleavage and fracture. So be sure you know the difference, because of all of these that we have here, color and cleavage and fracture are the ones that we use the most. The ones that we just kept coming back to lab after lab after lab. All right. Any questions about mineral identification? Feel free to ask now. I am here to answer them. Any questions? I'm going to let you come up with them as I erase this. So. Okay. Anybody? Okay. All right. I see nothing there. So let's get into talking about the rocks. We're going to start with my favorite, igneous rocks. All right. I'm not going to ask you to make the chart. It's not going to happen. Yes, I will ask you to name 6 physical properties. I will only ask you to explain the cleavage and the fracture. I will want you to know the difference between the two, because it's very important going forward with all the rest. So the question on here, question 3, I'll even read it off to you. Question 3 is name 6 of the 10 possible ways to identify the physical properties of a mineral. And then I will ask you question 4, explain the difference between cleavage and fracture. So, actually, before we jump off of the minerals, defining the characteristics of a mineral, so do you guys know the 2 things that define what being a rock is? Like, what 2 traits does a rock have that distinguishes it from like anything else on Earth? There are 2 traits it will have. Do you guys know what those are? We got it. Okay, inorganic, very good. Inorganic is one, very good. And there's one more. And this one's a tough one. So inorganic. And there is something about how the rock is made up. I will use the word up, not, okay, we're close. So hardness can be a part of this, but let me give you the word structure. There's something about its structure that makes it, that defines what it is. Yes, very good, Ashley. Yes, a defined crystalline structure. So it basically means that a mineral, as you look at it, will have the same crystalline structure if you were to look at another identical version of that rock, right? So I'm asking you that because I do see a question here on the test that I have written is, which of the following, I'm going to ask you, which of the following is not a characteristic of a mineral? And as long as you know that those 2 are, it will be very easy to answer. So, all right. So igneous rocks. All right. So on the test, question 5. Question 5 is a lightly colored igneous rock is blank, and a dark colored rock is blank. So the question is, how do we know light? So what do we call a lightly colored igneous rock? Lightly colored. You have gone outside after a volcanic eruption and the rocks have solidified. You pick up a rock and it is light in color. Here, let's get some examples. That's right. You pick up this one. You pick up this one, right? So you pick this up and you're like, huh, yeah, that's right. So it is Felsic. All right. Jaden, the properties of minerals, you can go back after we are done here and you can see what I had talked about there of the 10 properties of the minerals. All right, so a rock is felsic, but a dark colored rock is what? This thing right here. What would you call this? What we got? A dark colored igneous rock. What is this? Yeah, Seth, that's right. Mafic. All right. But wait, there's one more. There is a mix of both. A mix of both. So if I were to give you, I'll go find it, hang on. It is steeped in mediocrity. It is intermediate, that's right. Intermediate, as it has equal or close to equal quantities of both. Equal or close to equal. All right, so intermediate. All right, so what does, when we talk about the colors of the igneous rocks, right? What are we referring to? What trait of igneous rocks are we referring to? There are two that we help to identify an igneous rock. What are we talking about here? What does this tell us about those rocks? What we got here? What does this tell us? So it does. Yes. Okay. Perfect. Seth, Daniel, Xavius. Perfect. We have all of them right there. Okay. So Daniel, yes, it does tell us the composition. The composition. This is the composition, right? Okay. And yes, the silica content and the iron content. That's perfect. So let's talk about that. So a lightly colored rock that is felsic is high in which? Silicates or irons? Oh wait, I see that there. Yeah, perfect. So felsic, let's actually let's put a label to these. All right, so the one that is high in silicate but low in iron, which one is that? Which one is that? Felsic or mafic? High in silicate, low in iron. We got it. Felsic or mafic? High in silicate, low in iron. What we got? Which one? We got it. Come on, chat. Don't leave me hanging. High in silicate, low in iron. Hey, that's the stuff. Felsic. So high in silicates, low in iron. Inversely, and as you put there, and vice versa, that is correct. So high in iron, low in silicate. Perfect. And then what does that mean for intermediate? This says felsic, high in silicates, low in iron. Is that hard to see? That is a little hard to see. All right, let's see if I can switch out for a brighter red marker. All right. High in silicates. And equal composition of silicate, very good, very good. That is intermediate, that's very good, yes. So, equal. So, yeah, roughly equal. All right. This is actually a really good time to talk to you about the bonus question. So there are two bonus questions. There are two. And the first one is, what is Mr. King's favorite rock? And I will show you. What is this? Anybody? This is the bonus question. I have paraded this in front of the class every time, every class period. That's rhyolite. That's correct. That's correct. That is the answer to what is Mr. King's favorite rock. But inversely, I have shown you what is Mr. King's least favorite rock. And again, I've told you that this rock is steeped in mediocrity. It is the potted plant of igneous rocks. What is this? What is this? Andesite. Very good. Very good. Those are the 2 bonus questions. So there we go. We got that out of the way. Okay. All right. So let's go back to the test. Let's go back to the test. All right. And what I'm going to talk to you next about is what is the difference, question 6 here. What is the difference between an intrusive and an extrusive rock? So what is the difference between an intrusive and an extrusive rock? So anybody want to take a stab at that? So we have intrusive, intrusive, extrusive. All right. Anybody want to take a stab at that? Tell me what is the difference between these 2? Perfect. Perfect. That's 1. Now go ahead. Give me that second one. All right. And what about the extrusive? Extrusive would be, yep, cooled on surface. Cooled on surface. So intrusive, cooled inside the earth. Extrusive, cooled on the surface. Neat. That is question 6 on the test. So now what I'm going to ask you for question 7. Question 7 is how would you distinguish between an aphanitic and a phaneritic rock? Aphanitic and phaneritic. What is the difference? Aphanitic and phaneritic. That is question 7. Is how would you distinguish between the 2? What is the defining feature when we talk about these? What's the difference? Anybody? What is the difference between an aphanitic and a phaneritic rock? Anybody want to take a stab? Aphanitic, phaneritic. I'll show you the difference. How's it? So here is a phaneritic rock. Let me go see if that works. Hold on, let me go back to the phaneritic rock. This is diorite. Okay. I know it's not super clear. Well, I'll see if I can get it closer. Not this way. This way. Okay. Yeah, right. Phaneritic. Okay. And aphanitic. This way. This way. What is the difference between these 2? What is the difference? Anybody want to take a stab at it? All right. No? Going once? Going twice? Okay. Now let's talk about that. Hey, that's right, grain sizes. There you go. Yes, the crystal size. Crystal size. So when you have something that is aphanitic, this is an aphanitic. Yes, perfect, Gabriella, perfect. Yes, aphanitic, small crystals. Right? Phaneritic, big crystals. So let me ask you this. I asked you this question, these 2 questions, back to back for a reason. So if something is aphanitic, where did it cool? Where did it cool? If something is aphanitic with small crystals, where did it cool? Was it intrusive or extrusive? Small crystals. Let me actually move so you guys can see this. Extrusive. Perfect. Extrusive. So inversely, we know then that if something is phaneritic, it cooled inside the Earth, intrusively. So aphanitic, small crystals, because the crystals do not have time to congregate and gather together, right? And phaneritic, because they have cooled beneath the Earth and had time to come together and start to form into various groups of minerals. Okay. So there's one last question on igneous rocks I'm going to ask you. And I'm going to ask you to define what makes a rock porphyritic. Define what makes a rock porphyritic. So when we talk about a porphyritic rock, I will tell you that we are talking about cooling yet again. So remember, composition, right? But we also talk about texture. Okay. So what makes a rock porphyritic? Okay, not quite. That gets us into pyroclastic when we talk about vesicles. Remember that vesicles, when you throw something through the air or it cools, right? When something is porphyritic, so remember the chart. The chart, I had aphanitic, phaneritic, and then right below the two of them was porphyritic. So what makes a rock porphyritic? And we're talking about cooling. We're talking about how it cools. Anybody want to take a stab? Want to take a stab? Stab. No. Go once. Go twice. Last chance. Okay. A porphyritic rock cools both inside and outside the Earth, right? So let's take, again, I like this piece of rhyolite because I can use it for almost everything. I don't know if you can see it through the camera, but that's not very clear. Anyway, so this piece of rhyolite, and I paraded in front of the class almost the entire time, has these strange salt and pepper crystals in here, right? Which are larger than the surrounding crystals. So what that means is that this potassium feldspar inside this rock, right, started to cool inside the Earth. But it just so happened that around the time it decided to start cooling, it was extruded. There was an eruption of some sort, and the material was pushed outside the Earth. And the rock, the aphanitic textures here, cooled around those phaneritic textures, right, and encased it. So when I ask you to tell me what makes a rock porphyritic, is I'm asking you to describe how it cooled. Is that it cooled both inside and outside the Earth. That is the fairly simple answer that I will take. Basically, you will see that it will have different size crystals. So be sure to tell me that the crystals will be of different sizes and that it cooled in different places. How are we feeling about this? I'm not going to move on because we're about to finish igneous rocks. So if you have any questions so far about what we've talked about here, I am going directly off the test, by the way. Everything we're talking about is on the test. So, like I said, I'm actually reading a lot of those questions directly off of it. So, any questions about igneous rocks before we move on to sedimentary? Right. Once. Going twice. And good to go. All right. All right. So we're going to go and we're going to talk now about, I have sedimentary and metamorphic actually together because that is the shortest portion. That is the shortest portion of the test. The shortest portion of the test is sedimentary and metamorphic. Okay. So I am going to ask you, which of the following is not a step in forming sedimentary rocks? So let's actually talk about that, about how you form, a sedimentary rock. Okay. let's talk about how we form a sedimentary rock. All right. So, do you remember, as I erase this, do you remember the 4 steps? The 4 steps that go into creating a sedimentary rock. Even if you don't remember them right from the start, we'll put them in order. Just give me what you know. Give me what you know. Steps to creating a sedimentary rock. See what you get. Steps to creating a sedimentary rock. There are 4 that we talked about. I believe it's 4. Yeah, it's 4. Weathering. Perfect. Weathering is the first. Right, so weathering. Let's go down here. All right. Deposition. Over here. 2 more. Transportation. Very good. And the very last, A, perfect, lithification. All right. So let's talk about weather. There are 2 ways we can weather something. 2 ways we can weather something. What are those 2 ways? 2 ways we can weather something. Jaden, it is a mix of multiple choice and matching and short answer. Mechanical and chemical, very good. All right, mechanical and chemical. Okay, so remember, you have watched me mechanically weather rocks all semester so far. So mechanical weathering is taking a physical change that is able to be measured. The physical changes will be measured by particle size, right? But chemical, remember, chemical breaks it down to its ionic bonds. But the one we're really interested in here is going to be the mechanical. It's going to be the mechanical. So, would any of you, adventurous spirits, like to give me the 4 particle sizes in order? The 4 particle sizes in order for when you mechanically weather a rock. Mechanically weather a rock. There are 4 particle sizes. Gravel, perfect. Gravel, sand, silt, and clay, very good. Gravel, sand, silt, and clay. Perfect. Sear this into your brain. Gravel, sand, silt, and clay. Gravel, sand, silt, and clay. Gravel, sands, silt, and clay. One more time. Gravel. Ready for it? Sands.
Sands.
Sands? What's next?
Silt.
Silt. And what's the last one?
Clay.
Clay. Gravel, sand, silt, and clay. Thank you to my all-screen assistant. All right. So, if you know this order, you will be able to answer this question because what you're going to see is a matching section, and the matching section will have the particle sizes. So, all right. So, you have gravel, right? Which is 2 millimeters or larger. Well, we will grab a sample. I've shown the class this before. There's gravel in here. This is actually a conglomerate that has multiple types of particle sizes in it, right? This one is very noticeable because the largest ones that you can see, these pebbles here inside, are your gravels, and they are visible, quite visible, large enough. Okay. Oh. Okay. They're a little. 2 millimeters. Okay, I have an idea, hang on. But yes, you will be able to see those sizes. You can get a whole new one. The one over here, I can obviously tell it's been used like a bajillion times.
Here, give me a sec, I'll let you know.
Okay. They're actually going to be put into the chat. Into the chat. 2 millimeters and then 2 millimeters to 0.05 millimeters. Okay. All right. Yeah, they're going to be into the chat. So the gravels, you can see. You can actually see these, right? So that's gravel. But the sands, I've shown you sandstones before. I think I actually took one of these and just shattered it in front of you guys. You can actually, so if you've been to the beach, I mean, sand is something, we even have around here. Yes?
What is that one too?
0.05 millimeters to 0.002 millimeters.
Okay.
Yep. So sand, right? And this is the smallest particle size that you can see, single particle size with the naked eye. Okay? And then we have our silts. Let me get our silts. And remember that silt has a quality like flour, right? It has a flour-like quality, okay? And here we have a stone that is made up of a lot of silts. I think I've shown you this is one that has a fossil in it. That was kind of neat. Yeah, you can see like that scaly texture here. There was a fossil on this one at some point, okay? And then we have clay, which I will show you. You will see that inside of this, and here is, we're going to talk about how clay acts like a glue. Clay acts like a glue. And you will see that a lot of these are held together by something, and the silts and the clays come together and hold this, bind this conglomerate together. All right. So, you will need to know, thank you so much, you will need to know the particle sizes, but listen, if you remember gravel, sand, silt, and clay, I've said it a dozen times, and if you have the chance, say it to yourself a dozen more. Gravel, sand, silt, and clays, you will be able to put these in order from largest to smallest. But it will be a matching section that you will have the particle sizes, the particles themselves, and then the particle sizes, you'll have to match them up. So, okay. So, what is, let me ask you this, another test question here. When we talk about transportation, there are 3 ways you can transport something. I'm going to ask you for 2. I'm going to ask you for 2. So, what are the 3 ways? Let me use a different color, actually. The blue seems to be working out pretty well. What are the 3 ways that we can transport something? Transport one of these particles. Water, very good. Yep. Water is by far the most important. There are 2 more. 2 more. So we have water, right? Yep. Air, perfect. And there's 1 more. There's 1 more. Might have remembered. Yep, perfect. Gravity, perfect. Yes. Gravity. So water, air, and gravity. I'm going to ask you to give me 2. Ask you to give me 2. You can forget 1, or just don't. You can give me all 3. It's fine. But transport something. We have water, air, and gravity. All right. So deposition. Deposition is when the particle. There is something you will need to know here. What is dependent upon, how do I put this? What is dependent upon a particle's movement? So when we're talking about depositing something, right? That is when the particle can no longer go any farther because it runs out of what? What does it run out of? That is much closer than you would think. When something is deposited, it is a result of running out of something. What is it running out of? Anybody want to hazard a guess? Energy. Perfect. Daniel, perfect. Energy. Energy. So, and here is the part that you'll need to know for the test. The larger the particle, right? We talked about this. The larger the particle, the more energy required to transport it. More energy to transport. And so smaller, easier. Smaller is easier to transport. All right. So one last thing. Lithification. There are two ways you can lithify something. What are those two ways that you can lithify something? Two ways you can lithify something. So one is about, right? Yep, cementation, perfect. And there's one more. And compaction, yep. I'm so sorry for my terrible handwriting. So remember, you can cement something, which is oftentimes smaller particles will come together and bind together larger, or those small particles will come together themselves and bind together. Or compaction is when you have weight applied to an area, and over time that area lithifies. Also, when it comes to compaction, there's a way that you can tell using your mineral identification how you know something is compacted. Do any of you want to hazard a guess at how you know? If you were to look at a sedimentary rock and you'll say, wow, that's compacted. What trait does it have? That's right, it has layers. So therefore, if it has layers, does it cleave or fracture? Which one does it do? Cleave or fracture? If it has layers. It cleaves, that's correct. It cleaves because it has a flat plane, right? It's a flat plane. Okay, so this is the end of the sedimentary section. There will be questions about this on the test. Everything on here will have a question attached to it. So is there any questions you have about this? Any at all? Any at all? I'm going to start erasing it, but I'm going to leave it here in case like anybody in the future wants to stop and like watch or pause it. Okay, any questions at all? All right. Okay, we are going to get into metamorphic. Okay, metamorphic was our shortest chapter. So, metamorphic. All right, friends, say it with me. What are the two things that help create a metamorphic rock?
Heat.
What do we got? Wait, hold it, we'll come back to you. Two things that help create a metamorphic rock. Two things. Heat and pressure. Go ahead, what's it?
Heat and pressure.
Heat and pressure. Heat and pressure. And I'm going to write these real big. Heat. Right? Heat. Thank you. And pressure. Heat and pressure. heat, and pressure. That's how you create a metamorphic rock. Okay, so let's dive into, real quick. It's very easy to discern which rock was created through heat and which rock was created through pressure. Would anybody like to tell me how you know the difference between the two? How do you know? Perfect. How do you know which one was created through heat and which one was created through pressure? There's really, in the terms of the samples that we've looked at, there's really only one trait you need to look between to see which one was created through heat and which one was created through pressure. What is that trait? Think back to mineral identification, right? What we got? Foliation, perfect. I'm so proud. I'm so proud of all of you. Yes. Foliation. And what? Yep, foliation. Perfect, Gabriella. Perfect. Yes, foliation means layers. Foliation means layers. So, for instance, this phyllite that I've been breaking in front of the class, right, has these layers. I'm not sure if you can see them very well. Probably not. This camera's not great. Listen, it's really not. But, we work it out. Okay, so it has layers, right? Okay, I'm not sure if you can see that. Okay. But let's go back to the gneiss. Let's go back to the gneiss. The gneiss has no layers, right? And the gneiss, if you were to break it, and like I said, this is incredibly dense. It's incredibly dense. Would fracture. Would fracture. Okay. So the last portion of the test, I'm actually pulling it up right now. The last portion of the test will have a very, very basic, and I do mean very basic, mineral identification element to it. So I told you that I'm not going to ask you to remember the names of rocks. I'm not, period. Other than rhyolite or andesite if you want some extra credit. The last portion, I am going to tell you that I'm giving you an igneous rock, right? And that igneous rock, I will give you a picture of that igneous rock, and you will have to tell me whether it is felsic, mafic, aphanitic, or phaneritic. You will have to give me the traits. You will have to identify the texture and the composition. And when I'm telling you that this is going to be easy, I'm telling you that I am going to whoop. I mean, if you have studied, also if you're here, I think you're going to get it. So I will ask you again if it is felsic or mafic, talking about its composition, and whether it is aphanitic or phaneritic. Okay? There will be a picture. There will be a picture. Real easy. For sedimentary, I will give you a picture of a rock. And I will ask you to tell me something about its mineral sizes. That's all I want. Or its particle sizes. That's all I'm going to want. Really easy. Give me something about its particle sizes. I'm telling you that if you have come to class, if you have watched, maybe if you haven't made it to class, but you've watched my lectures that I've sent, it will be really easy. I just need you to tell me something about the particle sizes. And again, I will ask you to identify a metamorphic rock. Again, you don't need to know the name of the rock. You don't need to know the name. All I will ask you is, was it formed through heat or was it formed through pressure? That's all I'm going to ask. And you're going to have to tell me that. And remember, if you are trying to identify a metamorphic rock, you're looking for, it's made through pressure, it has these foliations. If it doesn't have the foliations, it's probably through heat. So, any questions at all? We have reached the end of the material as I have written it. Any questions? Any at all? This is the time. Yes, hold up. Yes, I am here. I'm holding. What you got, Seth? That's better. Any questions whatsoever? Listen, all I'm saying, okay. When I talk about particle sizes, I'm sorry, I will answer these. Okay, I'm going to answer these out of order. I'm so sorry. So when I talk about particle sizes, I'm going to ask you, does this have gravel in it? Does it have sand in it? Silt, clay, or maybe you don't have a mixture? I promise you, again, I promise you it is a rock you have seen. And I am not going to use a sample, or I'm not going to try and bamboozle you to answer this question. So when we talk about particle sizes, I'm asking you, you tell me whether it has gravels, sands, silts, or clays as its primary particle. Okay, let me go up to Ashley's question. The first thing I said about the rock question with the picture. Okay, so the igneous rocks, it's going to go igneous, sedimentary, metamorphic. You're going to have 3 samples to identify. But again, you are not giving me the name of the rock. If all you give me is the name, that doesn't mean anything. If I put a picture of rhyolite up there and you say, hey, that's rhyolite, that don't matter. What I'll ask you to do is for igneous rocks, you will have to tell me the texture and the composition. So basically felsic or mafic, or aphanitic or phaneritic. I can promise you it'll be one of those. I'm not going to do something that's porphyritic or glassy or pyroclastic. We are going to do something simple that you have seen. So, Jaden, maybe, I might have that. Let's see. And you got, okay, so what all can you study to prepare before taking the test? All right. I would say, listen, I understand that like hearing me talk can get rather tedious, but like go through and watch this again if you'd like to. And be sure to study I think the thing that I see the most people trip up on is a mineral identification. Make sure you know at least 6 of them out of the 10. And know the processes for sedimentary rocks. Sedimentary rocks is one of our most involved labs. So I would say that if you like, I know all of you seem to have a fairly good grasp. I parade igneous rocks in front of you guys a lot. But definitely on top of studying some of the other things, be sure to hit sedimentary and mineral identification really hard. That is where I do see the most people tend to stumble, is that right there. So, all right. Any other questions? I'm about to end this and go do my review for historical geology. So do I have any other questions? Any other questions? Okay, lab 6. So lab 6, I believe it comes back. I believe it comes back. The audio does come back later on. I think when I filmed lab 6, I cut it. The questions, good question, because I'm still working out some of the others. So far, I have 20 questions on here. 20 questions. That I will say that's subject to change. There might be a few more because, I mean, it's out of 60 points. So I want to make it where, like, if you miss one question, it's not as hefty of a point loss. So, yep. Okay. Well, if that's all there is, I'm going to end this here and just simply say, good luck. Good luck. Be sure to take your midterm because remember, again, if you miss it, I can't really help you. That it gets out of my hands. So, good luck and I will see all of you in class next week. All right. Thank you, and take it easy.